Function has an equation of the form y equals ax squared plus bx plus c, where the highest power of x is 2. The graph of a quadratic is a parabola. In this first video on quadratic functions, we'll be looking at some of the main features of a quadratic. To begin with, concavity and turning points. Concavity really is talking about whether it is concave up or concave down, as in, will the parabola be in a smiley face sort of form or in a frown? So if a is greater than 0, that is the coefficient in front of the x squared, then the curve is concave up and has a minimum turning point. So this would look like a parabola like that, where there'd be some sort of minimum turning point here. For a is less than 0, and the curve is concave down and has a maximum turning point. So it would be some parabola like this, concave down, where your maximum turning point is that point there. Now the turning point is also called the vertex or stationary point of the parabola. So we also call this, as well as being the turning point, in both examples, we call this the vertex. And also in both graphs, you'll notice that a parabola is symmetrical. So there's some sort of axis of symmetry. In this case, it's both on the y-axis for the parabola, where on one side it's reflected into the other side exactly the same. It doesn't always have to be that position, though a parabola is always symmetrical. So if my parabola was, say, sitting over here, then there'd be some axis of symmetry through the middle there. So it'd be the same on either side. Okay, let's look at some examples of parabolas. Graph the quadratic function y equals x squared minus x using the table of values. So in this case, we need to substitute into the table and then plot the points. So if we sub in minus 3, we're going to get a value of 6. Sorry, 12 rather. If we sub in minus 2, then we're going to get a value of, well, I'll just show you one example of subbing it in. Minus 2 squared minus 2. So that gives us 4, 6. So that'll be 6. And then minus 1, that would continue down, and that would be a value of 2. If I subbed in 0, it will be 0, and that's going to continue in that same direction, 6 and 12. And so if we plot those points, we get minus 3, 12, minus 2, 6, and continuing like that gives us our parabola. There's it's concave up. That's where our vertex is. And one of the reasons we know it's concave up is because our value here in front, the coefficient is a positive 1, which means it makes it concave up. Alright, sketching this next graph, x squared minus 1. So we need to show the intercepts as well. So one of the things we need to know about our quadratic function is that we can find the x-intercepts or zeros by factorizing and then making y equal to 0. So first of all, what do we notice about this quadratic? Well, it's concave up, and when x is 0, it's going to be minus 1, so it's going to go through the axis at minus 1, the y-axis. Okay, so let's now try and sketch this, showing the intercepts well. The y-intercepts are going to occur just like when we're doing straight lines. The y-intercepts are going to occur at x equals 0. So if we make x equals 0, we get y equals 0 minus 1, which is minus 1. So that's our y-intercept. And our x-intercepts occur at y equals 0. So when y equals 0, we get 0 equals x squared minus 1. And so there's a couple of ways to solve this quadratic. One of them would be to recognise that we can just, this is a difference of two squares, and so 0 is equal to x minus 1, x plus 1, and so our values for x are going to be 1 and minus 1. So that's going to be our 2 points there, and so we can draw our quadratic through that with our vertex. So that's going at minus 1 and 1, and this is our vertex. Our vertex at 0 minus 1. Alrighty, stating the domain and range of the function, we could see that the domain is going to be negative infinity to positive infinity, and the range is going to be the lowest y value is going to be negative 1, and that's going to go up to positive infinity. Okay, at this point we're going to move on and have a look at the axis of symmetry. So the axis of symmetry for the function, an axis of symmetry will occur using this formula, though once we've got the value sketched, you can often do it by observation, seeing halfway between the two intercepts. So let's have a look at this value here. It's minus b on 2a, where the b and the a just come from our general form of a quadratic. So the turning point of a parabola, in other words, the vertex, the quadratic function y equals ax squared plus bx plus c has a minimum value if a is greater than 0, and a maximum value if a is less than 0. Now the minimum or maximum value of the function occurs when we sub in that axis of symmetry value for x to find out y. And so it takes on these coordinates here. Now that notation looks fairly intimidating, but really, as we do an example, you should see that it's not that difficult. So find the equation of the axis of symmetry and the minimum value of the quadratic function y equals x squared minus 5x plus 1. So reading the question, we've got to find the axis of symmetry. So we're going to use x equals minus b on 2a. And also we are going to find the minimum value, in other words, the vertex. And once we've got that axis of symmetry, that can help us. All right, so subbing into this formula to find the axis of symmetry, the axis of symmetry is minus b, which is, b in this case is minus 5. So it's going to be minus 5 all over 2 times a, which is 1. So it's going to be 5 on 2. So that's the line x equals 5 on 2. That's where the axis of symmetry is. And because it's concave up, we're finding a minimum value. Now the minimum value is going to be equal to, well, the coordinates of the minimum value will be where we sub in 5 over 2 into the function. So we're going to find when x is 5 over 2, y is equal to 5 over 2 squared minus 5 times 5 over 2 plus 1, which is going to be 25 on 4 minus 25 on 2 plus 1, which will be minus 25 on 2, sorry, minus 25 on 4 plus 1, so which will be minus 21 on 4. So that means the vertex is going to be, well, the minimum value is going to be y equals minus 21 on 4. That means if I graph this, I'd have some axis of symmetry at 2.5, 5 on 2 there on the x-axis, and it would be some minimum value. It would be concave up, and the minimum value would occur down here at minus 21 on 4. Okay, so we're going to just try and capture some of the key ideas in terms of a bit of a summary here of quadratic functions. So we've got a standard form, y equals ax squared plus bx plus c, where the highest power of x is 2, and the graph of the quadratic function is a parabola. If a is greater than 0, then the curve is concave up and has a minimum turning point. If a is less than 0, then it's concave down and it's got a maximum turning point. A turning point is also called the vertex, or stationary point of the parabola, and the parabola is always symmetrical. These are basically the 5 skills with managing this equation. Determine the concavity,